In this lesson, we will look at cross product or vector product. So dalam video kali ini kita akan belajar cross product. Before this, we already look at the dot product. Sebelum ni kita dah tengok dot products. So hari ini we will look at the cross product. So the dot product of two vectors, let's say vector A and vector B, is denoted by vector. This is the symbol of the cross product. So the cross product of vector A and vector B. So before this, we look at dot product. If dot product, jika sebelum ni kita tengok dot product. So if dot product, the symbol will be dot product of vector A and vector B. So we'll use a dot. This is the dot product. If for the cross product, jika untuk cross product pula, so we'll use the symbol of multiplication. So this is the cross product of vector A and vector B. So this is dot product. This is cross product. Ini perbezaan dia. So now we look at the second definition. The cross product of vector A and vector B is defined as a vector C. So let's say the cross product of vector A and vector B, and the output is vector C. So vector C is said to be perpendicular or orthogonal to both vector A and vector B. So let's say, for example, the output for the cross product of vector vector A and vector B. Let's say the output is vector C. So katakan kita cari the cross product of vector A and vector B, and the output is a vector C. So vector C is said to be perpendicular or orthogonal to vector vector A and vector B. So the output for, let's say the output is vector C. So the vector C is said to be perpendicular or orthogonal to vector A and B. So let's say the question asks us to find the vector that perpendicular or orthogonal to vector A and B. So what we do is we just try to find the cross product of vector A and vector B. Then if you look at the third definition, the cross product of two vector, vector A and vector B, is a vector. So the output is a vector. Whereas for the scalar, for example, before this we learned about the scalar, the output of the dot product of vector A and vector B is a scalar. Whereas the output for the cross product of vector A and vector B is a vector. Maksudnya jika kita cari dot product hari itu, dia punya output dia adalah skalar. Maksudnya dia adalah nilai, satu nilai. Tetapi untuk cross product, output dia adalah vector. So next come to the question, how we going to find the cross product? Macam mana kita nak cari cross product? Let's say, let vector A is A1, A2, and A3. And vector B is B1, B2, and B3. Then the cross product of vector A and vector B is given by this one. So ini cara dia. What we do is, it's just like try to find the determinants. First, for the first row, we put I, J, and K. Dia macam nak cari determinants. So row pertama, kita letak I, J, and K. And the second and third row is the element in vector A and vector B. So untuk baris yang kedua dan ketiga adalah elemen dalam vector A dan vector B. So kita letak A1, A2, A3, B1, B2 and B3. So then we try to find, just like finding the determinants. Cuma beza dia sekarang kita ada I, J and K. Those the same thing, positive, negative and positive. So for example, calculate the cross product between vector A and vector B. So what I do here is the cross product of vector A and vector B is equals to, so the first row we put I, J and K. Row yang pertama kita letak I, J, K. The second row kita tengok A. A is 3, negative 3 and 1. So kita letak 3, negative 3 and 1. Vector B pula 4, 9 and 2. So we put 4, 9 and 2. So then we try to find the determinants. So don't forget, for determinants, positive, negative, positive. So that's why we have positive, negative, positive. So we have I, J, and K. And then just like before, close the first row for the I, close the first row and the first column. So kita tinggal negative 3, 1, 9, and 2. So here is the value. For J, close the first row and the second column. So we have 3, 1, 4, and 2. So here is 3, 1, 4, and 2. Finally, for the K, value of K, we close the first row and the third column. So what we have here is 3, negative 3, 4, and 9. So here is the value. Then try to find the determinants and the output. You can see that here is a vector. It's not a scalar anymore. So it's a vector. So notes you can see here, based on the second definition, this output, which is a vector, is perpendicular or orthogonal to both vector A and B. So just like before, let's say here is the vector C. So this vector C is perpendicular to vector A and B. If you look at example 1, for example, given that vector u is negative 3i plus 2j plus 4k, and vector v is this value, is this vector, determines the cross product of vector v and vector u. So just like I said before, in order to find the cross product of vector v and vector u, vector v and vector u. So this is equals to, so like try to find the determinants. First is I, J, and K. Since we start with the vector V, kita mula dengan V dulu. So kita letak V dulu, which is 2, 5, and 1. You can see it. This is 2, 5, and 1. Then the second row and the third row is negative 3, 2, and positive 4. So this is equals to, don't forget, here is positive, negative, positive. So let's say positive I, and then close the first row and the first column, 5, 1, 2, 4. 5, 1, 2, 4. The second column, the second value is negative. So negative J, first row, second column, 2, 1, negative 3, 4. 2, 1, negative 3, and 4. And finally is positive. And then here is K. So the first row, third column, 2, 5, negative 3, 2. 2, 5, negative 3, and 2. So here I have positive 5 times 4, 20, minus 2 times 1 is 2, minus J, 2 times 4 is 8, minus 1 times negative 3 is negative 3. Put a square bracket here. So plus K, 2 times 2 is 4, minus 5 times negative 3 is negative 15. So here we have 18i minus here is we have is 11j, and here we have 19 positive 19k. So you can put an arrow above the I and j and k, I, j, and k. So here is the output for the cross product. And this vector is said to be perpendicular to vector V and vector U. So maksudnya vektor yang kita dapat ni dia adalah berserenjang ataupun orthogonal to vector V and vector U. This is the cross product. So ini cara kita cari cross product. Let's say we can compare the answer. Exercise 1. 18, negative 11, 19. So if you compare with the... Yeah, so this is the answer. Negative 18i minus 11j plus 19k. So this is the answer for the exercise 1. Now we move to exercise 2. For example, given vector u and vector v and vector w. So we have three vectors. Find the vector q, which is orthogonal to both this vector, the sum of vector u and v, and vector w. So first thing first, this is orthogonal. So how are we going to find the orthogonal? We're going to use the cross product. Remember, the output for the cross product is orthogonal to the above vector. So next what I have to do is I try to find the sum of vector u and v dulu. So kita cari hasil tambah vector u dan vector v dulu. So the sum of vector u plus vector v is equals to, let's say u is I change to the coordinate form. Saya tukar dalam bentuk koordinat 2, 1 and negative 2 plus vector v. V is negative 1, 1 and 5. So here 2 plus negative 1 is 1. 1 plus 1 is 2. And then negative 2 plus 5 is positive 3. So this is the sum of vector u and vector v. Whereas for vector w is equals to negative 1, 1 and 2. So in order to find the vector q, which is orthogonal to both this vector, so what we have to do is we have to find the cross product. So means that q is first orthogonal to vector u plus v and vector w. So what we have to do is we try to find the determinants. So I is j is k. So the sum of vector u and v is 1, 2 and 3. So put here 1, 2 and 3. And the vector w is negative 1, 1 and 2. Just like we try to find the determinants. So first, don't forget, here is positive, negative, positive. So here is I, and then we cross 2, 3, 1 and 2. Negative j, the first row, second column, 1, 3, negative 1 and 2, 1, 3, negative 1 and 2, plus k, first row, the third column, 1, 2, 1, 2, negative 1 and 1. So from here, so 2 times 2 is 4, minus 3 times 1 is 3, minus j, 1 times 2 is 2, minus 3 times negative 1 is negative 3, plus k, 1 times 1 is 1, minus 2 times negative 1 is negative 2. So from here, 4 minus 3 is 1, 1i. So it's I, minus 2 minus negative 3 is 5j. And finally, 1 minus negative 2 is 3. So plus 3k. So this is the vector q, which is orthogonal to the sum of vector u and v and vector w. So, jika kita nak cari vektor yang ortogonal kepada dua vektor ini, so kita cuma perlu lakukan cross product. So, inilah hasil dia. So, this is the output.